Okay, good morning, everybody. So I am recording this live in front of my first hour for you guys in 7th hour. And I want you guys to turn to this page in your notes. You guys already there? You guys are going to listen to part of this on the podcast, but I want to use it to start with where we're headed. Okay? So, we've talked about briefly of metallic bonding. You'll hear more about that, a sea of electrons. Ionic bonding. You guys have been doing homeworks 1, 2, and 3 is ionic bonding. And why did we say electrons want to transfer? They want to become more stable. Good, Devin. So they want to become more stable to get a full sublevel of electrons. Today we're going to start talking about covalent bonding. And I want you guys to think of a tug of war, because that's what it is. Covalent bonding is where you are sharing electrons, okay? So picture yourself on one end of the tug of war and someone else on the opposite side. Neither of you are going to win the tug of war, but one side is going to be more dominant than the other, and depending upon what type of bond you have. So if I have polar covalent, I have unequal sharing of electrons, usually two nonmetals. So if you're on the tug of war here, is one side winning, but you're still holding on to the rope? Right? Okay? And where are the nonmetals on the periodic chart? They're on the right side. You're right. Okay, and then if I have nonpolar covalent, I have equal sharing of electrons, usually two nonmetals. So is anybody winning the tug of war there? No, that flag's not moving. It's staying right there. You're still holding on to it. You're sharing those electrons. Now, if we flip that tug of war to an ionic bond, is one side going to win? Yeah, because you're giving up electrons, right? And the other side's taking it in. So ionic bonding, yeah, in that tug of war, you're actually letting go of electrons and another one's bringing it in. But covalent bonding, you're sharing those electrons and they're always near you. And you're going to hear about electronegativity, which you did a little bit yesterday. Okay, so what I'd like you guys to do is flip over to this page. I think you have to flip your page over and get to that. It's a few slides over. Okay, so this is going to be a single covalent bond. So two atoms are nonmetals, share a pair of electrons. Weaker bonds only share one electron pair. Example is hydrogen. Okay, so what does this all mean? So the first thing we have to do is we have to find our total number of electrons. So look at where hydrogen is. How many valence electrons in hydrogen? One. I know it only has one, but it has one valence also, right? Okay, would you agree that I have two hydrogen in my example right here? So I have two hydrogen. Its valence electron is one. So I have two electrons that I need to put in my diagram. Okay? Now what we're going to do is we're going to draw our two hydrogen. And here's that electron for hydrogen. And if I draw my other hydrogen, here is its electron. So is it sharing electrons right now? So what this looks like, you guys, is here's hydrogen overlapping with the other hydrogen, and here are its electrons. So that becomes very stable. Now look at your periodic chart. If hydrogen has two electrons around it, what element is it acting like? Helium. Does it want to act like helium? So if I look at this hydrogen, do you see how it has two electrons around it? This one has two electrons around it. So now is it stable by sharing electrons? Okay, do you see how hydrogen really can't get there unless it takes in an electron, right? But it doesn't want to give up its one electron that it has, so it's going to share. Now, this could get really messy if the molecules get really large, right? These drawings. So the easiest way to do that, we are going to take our hydrogen, draw a stick, and draw another hydrogen. That's how we're going to draw that. So what does that stick represent? It represents a bond, okay? So this stick right here represents a bond of how many electrons? 2 electrons. All right, so circle that up so you remember that. Flip the page. Okay, next we're going to do a double covalent bond. So this was a single bond because I had one stick in the middle. Okay, now we're going to do a double covalent bond. Two atoms share two pair of electrons. It's very strong because it's sharing those electrons. So we're going to do the same thing. Look at oxygen. How many valence electrons in oxygen? 6. This is where you answer the questions, right? 2 times 6 is 12 electrons. Okay, so I got to put in my picture 12 electrons. Now, I'm going to draw my oxygen. I'm going to draw another stick, and I'm going to draw another oxygen. Now, what we have here is called an octet rule. What does octet mean? 8. 8 electrons. What family wants 8 electrons? You're right, the noble gases, okay? And so we're trying to get 8 electrons around here. Now, I want you guys to see this, that if I fulfill this, so that there's 8 electrons around each one, I'm going to have too many. So watch what happens. So this stands for 2, right? 2, 4, 6, 8. Is that the octet rule around oxygen? It wants to get 8. Does it look like it's satisfied? Okay, now let's do the same thing to the other oxygen. 2, 4, 6, 8. Now by themselves, is each oxygen satisfied? All right, now how many total electrons should I have in my picture? 12. I got 2, 4, 6, 8, 10, 12, 14 electrons in my drawing. Is that too many? Yeah, I got to take 2 away. How could I do that then? A double bond. So this is now going to become a double bond so that I can satisfy this. So this is going to be oxygen double bonded to oxygen. And with each bond, it's 2 electrons, right? So I have 2, 4, 6, 8. 2, 4, 6, 8. Okay, so now let's count total. I am going to use a different color so my 7th hour can see this. So 2, 4, 6, 8, 10, 12 electrons. So did I satisfy the 12 that I need? Yeah, so by adding a multiple bond. So this is how we're going to start drawing structures, and you guys can see some of the models that I have that have dimensions in the room, and some of them that are still left to hanging. We're going to build some back in lab that all the molecules have dimensions and they have different bonds between them. Okay, so then the third one that you guys have is a triple covalent bond. So this was single, double, and how many bonds do you think in between a triple? 3. Let's show you why. So nitrogen, look at nitrogen on your periodic chart. I have 2 nitrogen times the number of valence electrons is how many? How many? Nope. 1, 2, 3, 4, 5. 5, right? Okay, so 10 electrons. So let's try this one more time. I'm going to do nitrogen bonded to nitrogen because that's what I have in my molecule. And then I have 2, 4, 6, 8. That looks like it's good. 2, 4, 6, and 8. With this structure, how many total electrons do I have? 14, right? I have 14 electrons. So if I want to get down to 10, what does that tell you I need? 2 more. Yep, I need to take out 4, so I need to add 2 more bonds. Because when I take a bond, when I add a bond, it takes away 2 electrons. Add another bond, takes away 2 more. So I'm going to say nitrogen, 1, 2, 3, and my other nitrogen. Right now, would you agree that I have 2, 4, 6 electrons around each nitrogen? 2, 4, 6, 8, 2, 4, 6, 8. What do you think about the stability of that bond? It's really strong. there's the triple bond. When you're sharing that many electrons, it's a very strong bond. Takes a lot of energy to break that apart. Okay? Any questions with this so far? Can there be more bonds? Josh, great question. No. 3 is the most that there can be. Okay? Because then it would be incredibly unstable. All right? Good question. So we're going to talk about Lewis structure now. Those were pretty simple little things that we were just doing. Now we're going to make it so that we have molecules. So we still have to do our total number of valence electrons. So how many carbon in carbon tetrachloride right here? 1 carbon. Look up on the periodic chart how many valence electrons in carbon. 4. Excellent. 4. Plus, I have 4 chlorine. How many valence electrons in chlorine? 7. Good. Okay, add this up. 4 plus 28. I have 32 electrons that I got to show in my picture. Now, the first element, unless it's hydrogen, is going to be your central atom. So I look at this. I have carbon right here. Does it make sense to you that I can draw carbon in the middle and draw 4 carbon or chlorine around the outside? Okay, let's do that. So here's carbon. 1, 2, 3, 4. So look at that structure. Which element, carbon or chlorine, does it look like it's satisfied with the octet rule? The carbon, right? If I count the sticks, 2, 4, 6, 8. Is carbon satisfied? Yeah, and I've used 8 electrons, but I have 32 of them to use, so do I have a lot more to place? Okay, so if I look here, I have 2, 4, 6, 8. 8 times 4 is 32, so do I have enough to do everything around each one? I do. All right, so 2, 4, 6, 8, keep going around the outside to get the octet rule for each one of them. And there's our structure. So does each chlorine have 8 electrons around it? Does each carbon have 8 electrons? I have a total of 32. It looks good. Most of the elements we're going to draw in here are just going to be single bonds. We don't have to worry about multiple bonds. Okay? Okay, let's try the next one. You guys do this one before I do it with you. Do PBr3. See if you can get this one drawn. So find how many valence electrons with phosphorus, add it to 3 bromine, find your total. I suppose I could pause this. Oh, is it not recording? Okay. Okay. All right, here's the drawing that you should have just drawn for PBBr3. Hopefully you figured out that you needed to have 26 electrons. And then remember that when you go around and count, this is 2, 4, 6, 8. 8 times 3 is 24, 25, and 26. So that's what phosphorus tribromide should look like. Okay, we are going to ask you guys to do some naming of these again, so it might be a good idea to write that down. So this is phosphorus, tribromide. Okay, so now I'd like you guys to flip over to homework 4. I want to get you guys started on that, and then you guys can have some work time. So here's homework 4. You guys can go ahead and try to do number 1 in your notes. You should have that. So for number 2, it says draw the orbital diagram for 2 fluorine atoms. So we've been really good at drawing orbital diagrams now, right? So we can go ahead and say for fluorine, orbital diagram. Here's one of the fluorines, 1s, 2s, 2p. Do the same thing with another fluorine. and hopefully you guys are comfortable with this, right? And I have 1s, how many electrons? 2. 1s2, 2s, 2, and then look at fluorine, it's going to be 2p, add one more, 2p5, 2p5. Okay, so let's draw this up. Add one more. Okay, so we draw the two orbital diagrams in part A. Part B says circle the electrons that will be shared by the fluorine atoms to form a covalent bond. When you look at it like this, is it obvious why we're sharing? So when we draw these, this one is going to share with this one, and when they get near each other, what do you think is going to happen to one of their spins? It's going to point down. It's going to automatically spin in the opposite direction. That's just what's going to happen when the electrons get closer and closer and closer together. One's going to start spinning the opposite way. Okay? So hopefully the picture makes sense as to why they're sharing. And then it says draw the electron dot picture of the fluorine molecule. So the dot picture is going to be a fluorine bonded to a fluorine. That's the electron sharing. And then do we still have to obey the octet rule? Okay, so 2, 4, 6, 8, 2, 4, 6, 8. And when we look at that, you guys hopefully could recognize that the valence electrons are the highest electrons that we have. And if we look at this right here, would you agree that I have a pair, a pair, a pair, and then one shared right here, right? Look at that, pair, 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 and then one shared. Do you see how it follows the picture that we've been drawing? Isn't this awesome? Amazing? You can smile. It's okay. Chemistry sometimes will make sense, right? Sometimes. Okay, so down here, using your Vesper Gold sheet, which I haven't given you because you don't need it for this part yet either, add up the required electrons, draw the bond sketch, show all lone pair of electrons. Okay, so let me get you started on the first one. So we have silicon tetraiodide. So look up on the periodic chart, find silicon. How many valence electrons in silicon? 4, excellent. I have 1 silicon, so it's 4 plus 4 times, and iodine is 7. Perfect. They're going to think we guys practiced this lecture before I gave it to you guys. You're so awesome. All right, 28 and 4 is 32. Perfect. 32 electrons. Okay, what are we going to put in the middle? Mr. Buck, got that frog out of your throat? All right, so we're going to put silicon in the middle. And then we're going to put our 4 iodines around the outside. Okay. Yes, so do we have enough to satisfy everything? Yes. So I have 2, 4, 6, 8 already with the bonds drawn. And then if I go 2, 4, 6, 8, 8 times 4 is 32. So I have enough to put electrons all the way around the outside. And then tomorrow we'll start putting dimension on these because they're not flat molecules, but we start this way drawing them flat so we can figure out what dimension they have. Okay? All right, so this is what I'd like you guys to work on is these drawings right here. And I want you to circle or star or do something with the last 3. These are the ones that have multiple bonds. So meaning that they will have a double, single, or a triple bond. Those might be a little bit harder. I can help you with those, but you should be able to get the other ones completed. So if you finish this, keep working on homework 1, 2, and 3. Listen to the podcast that's due for tomorrow. You have plenty of work to do, right? Okay, 7th hour, have an awesome night. My first hour was happy to share a class with you, right? Sure. All right, have a great day. Bye-bye.